Welcome. In this session, we are going to be learning about comprehensions. Comprehensions in Python. And in the last class, in the last session, we learned about control flows. We start with conditionals, the if else statements. We looked at for loops. We look at while loops, and we also look at ways for us to combine, loops with uh, if statement. And that is kind of like what conditionals are, uh, to be honest. So let's switch this back to CPU. Right. Now, let's look at this particular example so that it will help us have a very, nice appreciation of what comprehension actually help us do. So let's say we want to write a program that checks if a number that checks want to write a program that labels a number as odd or even within 1 and 20. Let's say 1 and 20. So what this program will do is check the numbers between 1 and 20 and label them as either odd or even. So from what we've learned in the past, this is how you would do this. You probably um, firstly whip out an empty container, like something to drop those values in. So we could say, let's call it bucket. And bucket is going to be an empty list, could be an empty tuple, whatever we want to do. Then we can see for number in range. For number in range range 21. Or let's start from 1 actually. 1 comma 21. So what we are going to do is we are going to say if number modulus 2 equals 0, that is if number is divisible by 2 perfectly without remainder, we are going to say bucket dot append number, else we're going to say, oh, this is wrong, I'm thinking about something else in my head. So what we are going to say is if number modulus 2 equals 0, bucket dot append even, I'm going to put even in the bucket, else we're going to say bucket dot append odd, then we can come outside of that loop and print out bucket and see what our bucket looks like now. So if we should run this, this runtime is just connecting. Let's see. I think it is almost done. Yeah, so it's done. And we have odd, even, odd, even, odd, even. Like, okay, let's make this up to 10. So that is going to be cleaner. Or we can just print. That's another thing you could do. If we run that, yeah, perfect. So we see odd, even, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now look at the length of code, like the number of lines that we have to write to get this done. Although if you ask me, I'd say this is readable, right? So we get an empty container, we set up our for loop, we are doing our conditional check. But all of these lines, especially when you don't want something that is, this expressive, you just quickly want to get something like this out without doing too much. That is where comprehension comes in. So start with list comprehension. We'll call this list comprehension. So there is also dictionary comprehension that we're going to be seeing shortly. But now let's look at this. how can we actually write this the least comprehension way so that we can have good appreciation for least comprehension. So to write this exact program, say write the exact program above with least comprehension. So how can we do that? The way to do that will be to say we really do not need to do anything. We just let's say list, let's call this one list bucket equals, then we are saying even, and this is how list comprehension works, even if x modulus, or let's say number, if number modulus 2 equals 0, then we say else odd for number in range 1 comma 11. Then we can print out our outcome here, list bucket. And if we do not care about putting this in a variable, this code would have really been just a single line of code. So can you see the output? The same thing that we have to do with multiple lines here. We just have one single line of, in fact, if I should remove this variable, let's say I do not want this variable, I also do not want this variable here, and I can just run this and it works like that. And it is truly a single line of code. So it is this concise, let me control Z this. It is a very concise, straightforward way, very like compact way of doing loops and you know and conditionals and if else within an iterable, which in this case is a list. Very simple way of doing it. So instead of like going through these several layers and lines, you can really just write a single list comprehension that gets the job done. So, and comparing this, you're going to see that this is much more concise. But what I used to tell people, and this is like my personal opinion, what I used to tell people is you really should not throw comprehension at everything, because what it actually gives, especially when you're just starting out, what it gives you in compactness, I feel like it takes away in readability a little bit. So when this comprehension gets a little bit, you know, complex, that is when you are doing some advanced stuff and you're using this comprehension for it, it takes away from the readability. It is going to like be a little bit difficult for you to actually read what is going on. And it's the same thing kind of applies to lambda functions also. When we get to lambda function, you are going to understand better what I'm talking about. But let's look at um more examples of list comprehension. And there are like some things I need to point out regarding how list comprehension works. So let's look at example 2. I'm going to say write a simple comprehension or a simple program that returns all the uh, even numbers in what, in between all the even numbers between, or let's say all the multiples of 3 between 1 and 11 again. So in this case, we only have one condition, and you're going to see how we are going to structure that list comprehension. In fact, if we do multiple underscore 3 and we whip out our list comprehension like this, we start with the list bracket. So if we go, and in this case, what we want to see is we just want to see something like this. Our answer is going to look something like this. Answer is going to look something like this kind of list where it just goes 3, 6, 9, like that. I think it's just 3, 6, 9. Yeah. Now, if we want to do it's not something like odd, even labeling stuff. We just want to return those numbers. So it is just only one condition. Like if a number is not a multiple of 3, we are not touching it. We just leave it alone. So in that case, the way we structure the list comprehension is different, because if I can say number, that is return number for me, and it could be anything. It's an iterator. You could say X. That is, this thing here could be anything. Could be X. Could be anything. So if I say number, if number modulus 3 equals 0, is that right? Then you say for number in range 1 comma 11. Now you already see that it's giving us an error here. It's saying it's expected else, like it is expecting else, excuse me. So if we run this, it's going to throw an error, and I'm going to show you why. Multiple of 3. So it throws an error. I just wanted to see the error. So it's a syntax error. It says it expects else. So whenever you are structuring like this, the reason why this works is because we go if, else, then for. So if the only thing you have is if and there is no else, you structure your list comprehension differently. And how do we do that? The condition is actually going to be behind the for this for here. So let me just remove all of this and show it to you. So it's going to be something like this. Let me remove that. It's going to be number for number in range 1 comma 11. If that just one condition is fine, if number modulus 3 equals 0. So what does that mean? So if we run this now, we run this, we get our output 369. So the takeaway is, if I have multiple condition, if, else to check, then they are going to be in front of my for. However, if I have just only if the only thing I'm looking at is just if, I'm only interested in checking one condition, it is going to be behind my for, like this, and it is extremely important. That's like the first important thing to note about comprehension. The other important thing to know is that there is no elif. From learning control flow, we learned about elif, basically else if this, else if that is elif this. There is no elif in list comprehension. For example, let's write a program that I don't know, that checks if um a number is that checks if a number is I don't know what we can write. Let's look at this one here. If it is odd, even, or what. I'm struggling to find what we can do. Okay, let's say I want to write a program that check if a number is 0, odd or even. Yeah, let's do that. So let's write a program that checks if a number is 0. No, that doesn't make sense. Why are we out of ideas? Why are we out of ideas? Okay, let's maybe do this. So let's say Nigeria equals Abuja, Lagos, then Ibadan. Then we can go fruit equals um I don't know, kiwi, mango, and orange. Then we can go um player, because Steph, Messi, Neymar, like this. So what we now want to do is, let's say we have another list of some random stuff, and we want to label it either, okay, let's say country. So let's say we have another list, and we have a list of things, and in this list of things we have Abuja, Messi, Steph, Orange, and Lagos, like this. So what we're now going to do is, we want to write a comprehension that's going to check whether this something in this list of things, whether this is, whenever it sees this, it just changes this to country, changes this to player, changes this to Steph. Then our list of things is going to come back as whether it's a country, player and stuff like that. So if I should say, let's call it labels. If I should say labels equals, I'm going to open this comprehension up and go country if X in country. That is, if you find that thing inside this list of country, then label it country. I'm going to say else player, and you see, in this case you do elif, but here, like I mentioned earlier, there's no elif in list comprehension. It's else if, actually. So else player if X in player. Then we can go to the next line and say, sorry, else, what's the last one? Fruits. Say fruit for X in things. Now you're going to see, if we run this now and print out labels, this is not like the best example, but that's what I could come up with right now. So let me actually print things on top of it. Let me print things here. Print things. Then if we run this, at the top, we see the first one is Abuja, and it got it correctly as country. Second one is Messi, player, Steph, player, orange, fruit, Lagos, country. That is, Lagos belong to this particular thing. So the main takeaway from here is, how does list comprehension handle case of multiple conditions? So let's put that here and say Control Z. Z, multiple condition, case of multiple condition. Right. So how does that work? This is the way it works. So you say something if, something else if, not a leaf. So there's no elif in list comprehension, and that's really the second important thing to learn. So if you have multiple condition, you go if else, you know, you go like if else if else if else if else this thing for this other thing. And the second rule to learn is, if you only have one if, it has to go behind the for, not in front of the for. And I hope that makes sense. I hope that makes sense. You are going to see comprehensions a lot as we move on. And the ones that we've covered currently is list comprehension. So let's look at dictionary comprehension. Let's look at our dictionary. It's almost the same actually. It's just that dictionaries have key value pairs. So dictionary comprehension. You spell comprehension again. Comprehension. So how does dictionary comprehension work? The way it works is almost like the way list comprehension works. So let's say we have we have two lists, for example. Let's say we have two lists. We have list of, or maybe even a single list. Let's say we have list of numbers, or let's do this. We can say number label, or let's say number label is going to be equal. So whenever I want to start um what do we call it? Dictionary comprehension, we actually do so with we do that by starting with this particular um curly bracket. For the case of list, we do it with a list bracket. So it's a no-brainer that in dictionary comprehension we do it with that particular curly bracket. Right. So now let's take this example. Just let's write a program that returns a dictionary of um, a number and its square. So basically, what we are trying to do is we are going to get a dictionary where the key is going to be the number and the um, value is going to be the square of that number. So firstly, let me show you. This works without what do you call it? Without creating a variable. So how will that work? So we start off like I said with this. So we can say x and x star 2 for x in range. Maybe let's just say 1 and 11. So 1 to 10. So between 1 to 10, this guy is going to print out a particular number and its square. So if we run this, we have 1 and the square of 1 is 1, 2 and the square of 2 is 4, 3, the square of 3 is 9, 4, 16, 5, 25, like that. So we could save that in a variable and say num square dict equals this, and we can call out num square dict if we want, and it's going to return the same thing. So it is like the exact structure as a list comprehension, and the only difference we have is just the way we handle the key value pairing and the fact that you already know that it is going to start with the curly braces. Let's take one that includes conditional. So we're going to write a program that returns this exact thing. Uh, what is at the top? That returns a dictionary of a number. Let me say of a number of numbers. That's actually the correct English, of numbers and their square. And their square only for even numbers. So we say only for even numbers. And if you already guessed it right, so we can say even underscore square underscore dict, and we can go x star 2 star means square for x in range 1 comma 11. But I hope you haven't forgotten the rule with comprehension. The rule is if we have only one condition, in this case we have just one condition, and the condition is just even numbers. The if must be behind the 4. These are our 4, so the list must be at the back. So we say if x modulus 2 equals 0. So if we run this and check even square dict, we're going to have just for 2, 4, 4, 16, 8, where is it? 864 and stuff like that. So that is the way that works. And you could also do something like actually, let's say you want to invert a dictionary, and this is one of the situations where this come in handy. Let's say you have a dictionary of, let's say, Nigeria, and you have kind of like a state and capital kind of thing going on. So we say Lagos, Ikeja, Oyo, Ibadan, and you have Oshun, then you have Oshogbo. That's enough. And we just want to like flip this. We want to flip it over. We want to make the key become the value. Like one like flip it over. How can we do that? The way to do that would be to use the same stuff. We can say Nigeria equals, then we can go v, say value, comma, key. I'm sorry, value will map, not comma, key, right? Say for key, comma, value, because, well, this is the key currently, this is the value. So we are saying value, no, not values, value should now point to key for key, comma, value in. And don't forget that whenever you want to loop over a dictionary, you have to call dot items, else you are only going to be getting the keys of that particular stuff, of that dictionary. So we say for key, comma, value in Nigeria dot items. So we run that. We should go and run this. So we get Ikeja now pointing to Lagos, Ibadan now pointing to Oyo, Oshogbo is now pointing to Oshun. So that is basically how we do something like this. And there's really no limit to what you can do. You can zip things together. Let's say you have two lists, you want to like map them together. You can use them, you can zip them. For example, let's say you have a list, one list, um number, a number equals 1, 2, 3, 4, and you have letters equals, and you have A, B, C, and D. This is a mistake. You can actually turn it into a dictionary by doing something like this. You can say uh, X of maybe let's just go key and value. You can go key maps value for key, comma, value in zip number, comma, letters. So if we should run that, you get 1 maps A, 2 maps B, 3 maps C, 4 maps D. So you can do anything. You can do enumerate. You can anything. You can like do anything that you really want to do with comprehension. And again, comprehension just provides us, list comprehension, dictionary comprehension. They provide us with this very clean, easy way of doing loops with conditionals also, especially when it comes to iterables, right? So that is comprehension, and it has, a very vast, very common application in day-to-day activities in data science and analytics. So with that said, that is it on comprehension. I'm going to see you in the next one where we cover functions and some other cool stuff. So see you in the next one.